Welcome to section 11.5. We're going to talk about slope-intercept forms. So we're going to talk about a particular way that we can write things to help us to plot graphs and so on. The first thing, there's not a lot of vocab. Here's our one vocab word, slope-intercept form. Make sure you get that in your notes. But the first thing that I want you to do is to do this right here. I want you to plot these equations, find some points, make a t-table and put in some xy points and figure out what the slope is of that and figure out the y-intercept. In other words, where does it go across the y? I want you to stop the video right now, even before you start, and I want you to do those three on a piece of graph paper. So go ahead and do that right now. Okay, so if you haven't, I want you to write in the answers for these right here and right here. Put them in the box or put them in, make a box on in your notes, and I want to see it. So make sure you do that. Okay, so let's take a look at a couple things. First of all, notice that every single one of these starts with y equals. And then we've got some form of x right here. So we always have just one y. We never have anything more than one. And then whatever x happens to be, whatever the value in front of x goes there. And then we've got a number here at the end. So I want to make sure that we understand how this looks here. So let's get some of this out of the way here. But now if you did this and you plotted these, you should find a slope of 3, 1/4, and -2. And what I want to point out is notice how that's 3, that's 1/4, that's -2. It is exactly what those are right there. All right. Now you also were to plot the y-intercepts, and if you do that, you'll notice that they come out to be 2, -1, and 3. And look at that, 2, -1, and 3. So what we have here, this is known as the slope-intercept form. And what this tells us is, well, here's what they've got here. So in other words, we've got this. If we put it in this value y, whatever we have in front of x, this value, they call it m. Over here it was 3, here it was 1/4, and so on. Whatever that is, that's our slope. Okay, so that's the slope. And then whatever came after it, in other words, that would be this number here, the 2, or the -1, or the 3. That's our b. That is always the y-intercept. That is where we cross the y-axis. So if we write this in a form where we get y equals something x plus a number, then we have what we call y-intercept form. And that's a very handy way of knowing exactly what the slope is, knowing exactly where it crosses the y-intercept so we can plot it. It makes it very easy to do some of those things. All right, so if we look at this one, it says state the slope. Oh, that's easy. Slope. And the y-intercept. Okay? Remember, the y-intercept, it's always going to be mx plus b plus, not minus. So if this is a minus sign here, you can think of it as 2/3 x plus a -4. So therefore, -4 is my y-intercept. So 2/3 is my slope, and -4 is my y-intercept. Now, if we have one that's like this, it's not completely written out that way, then what we want to do is get it in this form. We want to make it so that y is first, so that we've got some value of x plus whatever is left. We want to do that. So we need to get this x over to the other side, because y is good here. I want it on the left. I want it all by itself. So the easiest way is to subtract x from both sides. So subtract x, and I end up with y equals 6 minus x. But remember, I want it in the form mx plus b. So I am going to switch that around a little bit, and I'm going to say y equals negative x, or you could say negative 1x plus 6. So now it's in the form mx plus b. Therefore, my y-intercept is 6, and my slope is negative 1. And so just from that line, we can quickly, easily figure out, or just from that equation, we can easily figure out what the slope is, what the y-intercept is. We could plot it if we wanted to do that pretty easily, pretty quick. All right, so now let's say we do want to graph something. So we've got the graph. It says graph y equals negative 3/2 x minus 1 using the slope and the y-intercept. Well, we know that negative 3/2 is our slope. We know that negative 1 is going to be my y-intercept. So if it's the y-intercept, we know that that is the point 0, negative 1. Okay? 0, negative 1 for my y-intercept. That's where it goes across the y-axis. And if we know the slope, so for instance, we say, hey, the slope is negative 3/2. Remember, the slope was the change in y over the change in x. So what we know is we know our y units, negative 3. We know our x units, positive 2. So if we want to think about it, so here we go. We're going to take this point. We're going to plot it. 0, negative 1. And now what I'm going to do, negative means down if I'm talking about y. So I'm going to go down 1, 2, 3. And positive for x means to the right. So I'm going to go 1, 2. Now here's another point. Once I have 2 points on the line, that's easy. Now I can just draw the line through those 2 points. So I only need 2 points to create the line, and we're going to do that. Okay, I want you guys to stop the video now, and I want you to do this, and I want you to graph them using the slope and the y-intercept. So get a piece of graph paper, put it down, write it out, do it exactly.
All right, I'll give it a try.
No. Try not. Do. Or do not. There is no try.
All right, for the first one, we have y equals x plus 3. So we know the y-intercept, 0, 3. So let's go. 0, 1, 2, 3. Right here. That's my y-intercept. If there's no value in front of the x, then we know that the slope is 1. That means we're going to go up 1, over 1. Here's my next point. Here's my, can't draw very straight. Here's my line. Should be going up 1, over 1, or down 1 every single time. So there's my line that I would get for that first one. All right, let's take a look at B. It says y equals 1/2 x minus 1. All right, so let's start with our y-intercept. We know the y-intercept is going to be 0, negative 1. So let's go to 0, negative 1. That's right there. 1/2 means I'm going to go up 1, over 2. So let's go up 1, over 2. There's my next point. And I just draw that line. I would use a ruler unlike what I'm doing here, so you get a nice straight line. Up 1 over 2 should always be going, I didn't do a very good job because the next one should have been here and the next one should have been there. So my graph should have been kind of more like that. Okay, you of course did a much better job, I'm sure, when you were doing it. All right, and the third one, let's do the last one. It says y equals negative 4/3 x plus 2. So y-intercept is going to be 0, positive 2. So here it is right here, 0, 2. And here's my slope. I'm going to go negative 4. So we're going to go y negative 4. In other words, down 4. 1, 2, 3, 4. and then over 3. 1, 2, 3, right here. Now, I want to point something out, because sometimes people get confused about this. You got this, what if you have -4/3 and they say, well, where does that negative go on the top? Does it go on the bottom? It doesn't really matter. Up to now, we've always been doing it on the top, which is fine. You can do it all that way all the time. But let's say that you did it on the bottom. So, in other words, here's my starting point, my y-intercept, and I go up 4. 1, 2, 3, 4, and to the left 3. 1, 2, 3. And now if I make this line, notice that this line goes here, goes there. It doesn't matter. It still is part of that line, no matter which way you do it. But, do whatever's easiest, and if it's always easiest to put the negative sign with the top number, then just do it with the top number and keep going. All right, let's go back to, come on. Go back here. There we are. Okay. And let's take a look at this last example. Maybe. We'll get here. Last example. All right, so graph an equation to solve a problem. So let's take this as a story problem. Let's say we have the student council wants to buy posters advertised in school's carnival. The design shop charges $15 to prepare the design. So that's just kind of your cost for no matter how many you print. And then it charges $3 for each poster. And the total cost we're going to say is Y. And so here's my formula. So now look at this. Let's think about this. The total cost we said was Y. 3 times X. However many posters I print, there's $3 a piece. So 3 times X. So if I printed 10, it's going to be 30. But I've always got the $15 initial cost no matter what I get. So that's my formula that I have. And from this formula, I can now figure out what my cost is going to be if I decide to print 10, if I decide to print 100, or if I decide to print 1,000. It doesn't matter. So I've got this graph, and my slope, or my y-intercept, is going to be 0, 15, so that's there. And then I'm going to go up 3 and over 1, and this is a pretty small graph, so it's kind of hard to see. But then they plot this whole line here, and anywhere along that line would give you what we want. So if we wanted to print 10 graphs, or 10 posters rather, 10 posters, it's going to intercept right there. That's going to be my cost. It looks like 10 posters is going to be about $45 right there. And I could figure that out for anything on any of those. All right, I want to do just a little bit more. Okay, for number 5, you got y equals -1/6 x . Okay, so what I want you to do now is I want you to do number 5 and number 6, and I want you to bring those to me, kind of highlight them when you show me your notes, and I want to make sure that you did those correctly. I'm not going to go over them now, but I'll go over them with you when you bring me your notes. So do numbers 5 and 6.